Today we're going to talk about electron configuration. So just a reminder, you do need your periodic table and you are going to need your flowchart readily available in order to do this. They will be very helpful to you. So go ahead, take a minute, pull those out, and we'll go ahead and get started. Okay. Like I said, today we're going to talk about electron configuration. It is very similar to orbital diagrams. It follows the exact same rules. You're still going to use the flowchart in the same order. You're going to start and follow the red arrow. So it goes 1s, then it goes 2s, and then it goes 2p, 3s, and then it goes 3p, 4s, and then 3d, 4p, 5s, and then you continue to follow the red arrows. It does not go all s's, all p's, all d's, and all f's. Okay, so let's do a quick review. How many orbitals and how many electrons can they hold? S, remember, can hold how many orbitals? 1. How many electrons can S have? 2. P can hold how many orbitals? 3. And have 6 electrons. D can have how many orbitals? 5 and 10 electrons. F can have how many orbitals? 7 and electrons? 14. Very good. So before, when we were doing orbital diagrams, we would draw the boxes to represent the orbitals. Anytime we had an S, we would draw one box. A P would be 3, a D would be 5, and F is 7. Now we are simply going to not draw boxes anymore and just write it out. The big number in front is going to represent your energy level. The letter S, P, D, or F is your orbital type, and the exponent is the number of electrons in the orbital. Okay, so what does it look like? Here we drew the orbital diagram for nitrogen. Now we're going to get rid of the boxes and change the total arrows into exponents. So here we had 2 arrows, so the exponent becomes 2. Here we had 2 arrows, so the exponent becomes 2. Here we had 3 arrows, so the exponent becomes 3. Okay, so 2 plus 2 is 4, plus 3 is 7, and we know number 7 on the periodic table is nitrogen. All right, let's do some practice. Here we have our orbital diagram, so we're going to write our electron configuration. 1s, 2, 2s, 1. There were 2 arrows here, so we have our exponent is 2. There was 1 arrow here, so our exponent is 1. There are 3 electrons. 2 plus 1 is 3, and element number 3 on the periodic table is lithium. We did still follow the flow chart. We went 1s, and then we went 2s. Let's try the next. All right, practice problem number 2. We have 1s, 2s, 2p, and it follows our path. We're going to write the electron configuration. 1s, 2, there's 2 electrons. 2s, 2, there's 2 electrons. 2p, 3, 1, 2, 3. We did not go to 2p until 2s was filled. Our number of electrons, 2 plus 2 is 4, plus 3 is 7. Element number 7 on the periodic table is nitrogen. All right, let's try another one. Here we have practice problem number 3. We have our orbital diagram. We did follow the yellow brick road. 1s, 2s, 2p, 3s, and then we went back here and started 3p. We did not go to 3p until everything else was filled. Now we can write 1s2, 2s2, 2p6, 3s2, and 3p4. Notice S never goes higher than 2 and P never goes higher than 6. We can add our exponents. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 4 is 16. Element number 16 on the periodic table is sulfur. All right, let's do some more practice. I'm going to exit full screen mode so you can see me as I do it this time. Here we have fluorine. If we look at your periodic table, we see that fluorine is element number 9. So if it's element number 9, there are 9 electrons. We can use our flow chart to start. We have 1s2. After 1s comes 2s, 2s2. After 2s comes 2p. Now we need 9 electrons. 2 plus 2 is 4. So we need 5 more, so it will be 2p5. So 2 plus 2 is 4, plus 5 is 9. Now, if you want to make the exponents, you can. Or if you want to make these numbers exponents, you can, or you can leave them like this. If you want to make them an exponent, you can do format, text, superscript. Okay. or you can just leave them as they are. Okay, so that's fluorine. All right, let's do another one. All right, our next element is phosphorus. Take a look at your periodic table. How many electrons does phosphorus have? Phosphorus has 15 electrons. We are going to start at the top of our flow chart. We're going to do 1s2, 2s2, 2p6. Now let's count them. 2 plus 2 is 4, plus 6 is 10. I'm going to put a 10 in parentheses just so I can help track my numbers, and then I'll delete it at the end. After 2p comes 3s, so 3s2, so that's 12. I still need 3 more. After 3s comes 3p, 3p3. So 2 plus 2 is 4, plus 6 is 10. If you did write this in parentheses, remember you don't count it again. So 10 plus 2 is 12, plus 3 is 15. Okay, I'm going to delete the 10 because this is my final answer. All right, let's do another together. Let's do iron. Iron has how many electrons? 26. Good. The atomic number is 26, so there's 26 protons. 26 protons is 26 electrons. So let's get started. We always start at the beginning. You always start with 1s. S can have 2. After 1s comes 2s. 2s can have 2. After s is p. 2p6. P can go up to 6. After 2p, you go to 3s. After s can hold 2. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. I'm going to put 12 in parentheses so I don't have to keep counting. After 3s comes 3p. P can go up to 6. Okay, we need to keep going. After 3p comes 4s. S can hold up to 2. After 4s comes 3d. Now d is a very large number, so D can hold up to 10, so I want to stop to count here to see how many more I need. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, and we knew that. We had 12 in parentheses, so 12 plus 6 is 18. 18 plus 2 is 20. I'm going to put 20 in parentheses. So I only need 6 more. So after 4s comes 3d, and I only need 6 more, so it's going to be 3d6. Now I can go back and delete everything in parentheses, and this is my final answer. All right, let's do one more together. Let's do iodine. How many electrons does iodine have? Iodine's atomic number is 53, so the protons are 53, and that means your electrons are 53. So we start at the beginning. We start at the beginning with 1s. Remember, s can have 2. I think that's on. Let's make them bigger. So 1s2. Good. After 1s comes 2s. So 2s2. After 2s comes 2p. Remember, p can go up to 6. After 2p comes 3s. After 3s comes 3p. And p can go up to 6. After 3p comes 4s. S can go up to 2. After 4s comes 3d. Now remember, d's are very large, so I am going to stop and pause here and count. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20. I'm going to put 20 in parentheses and carry on. After 4s is 3d. D can go up to 10. After 3d comes 4p, so 4p6. After 4p comes 5s. After 5s comes 4d. Remember, d can go up to 10, and that was a very large number, so I'm going to stop to pause and count. I had 20 here. 20 plus 10 is 30. 30 plus 6 is 36. 36 plus 2 is 38. 38 plus 10 is 48. So I only need 5 more. 53 minus 48 is 5. So after 4d comes 5p, so 5p5. 5 because I only needed 5 more. All right, we can double check and count. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, 18 plus 2 is 20, which we knew. 20 plus 10 is 30, 30 plus 6 is 36, 38, 48, and 53. Okay, so we are all set. We can delete the parentheses, and then this will be our final answer. Okay, how are we doing? We okay? All right, let's keep going. So just as a review, what's an anion and how does this affect electron configuration and orbital diagram? Remember, anions are negatively charged and they always gain electrons, so you would add more exponents or you would increase that exponent number of the last one. Oppositely, you have cations. Cations are positively charged, and as far as electrons or orbital diagrams, you would take arrows or you would decrease the number of exponents, so you would lower that number. Okay, so if we had Na plus 1, I'm going to go back to here. The answer is actually already there. I'm going to delete it really quick. Sodium should have 11 electrons. So if we write it out, it should be 1s2, 2s2, 2p6, and then 3s1. 2 plus 2 is 4, plus 6 is 10, plus 1 is 11. But we want plus 1, so we're actually just going to delete that last part, and then this would be our final answer. Okay? All right, I'm going to go back to full screen mode now. So the exponents in the electron configuration can tell you the name of the element. If you add up your exponents, you get the name of the element. So I want you to identify the name of each of the following elements. Pause the video as soon as the next slide appears and do the practice. Okay? Pause the video, take a minute, do these problems. All right, hopefully by now you took the time to figure out the answers. The first one is manganese, then you have tin, then you have rubidium, then you have silver, and you have tungsten. Remember, in order to get the elements, you simply add them up. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, 18 plus 2 is 20, 20 plus 5 is 25, and element number 25 on your periodic table is manganese. Okay? All right, so do you think you have it now? Let's add in the valence electrons that we talked about last week. We were also talking about valence electrons when we were drawing our Bohr models. Remember, we were putting boxes around them or circling them. Where were they found? They were found in the highest energy level or the outermost orbital diagram. Okay, so they're still going to be in the highest energy level. So if we take a look at this, our highest energy level here is 2. Remember, the energy level is that big number in the front. So the highest energy level is 2. There is 2s and 2p, so we're going to add the exponents from 2 together. 2 plus 3 is 5. So it has 5 valence electrons, and we know if it has 5 valence electrons, it is in group 15. All right, let's try another. Here we have cobalt. Our highest energy level is 4. Even though it's not the last one, 4 is still our highest. The exponent with 4 is 2, so it's going to have 2 valence electrons. Okay, I want you to take a minute and do some practice on your own. Okay, so what is the highest energy level? The highest energy level is 4. The element is nickel because you add up the exponents, and your valence electrons is 2. All right, let's try another one together. What element is this? We have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 2 is 14. Element number 14 is silicon. The valence electrons, the highest energy level here is 3. We're going to add the 3's together. 2 plus 2 is 4. Okay, great. Let's try another one. What element is this? 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 is 17. What element is number 17? It is chlorine. Our valence electrons, we look at the highest energy level. Our highest energy level is 3. 2 plus 5 is 7. And we know it's 7 valence electrons. Okay, let's try another one. And there's actually a typo in this one. I'm going to go ahead and fix it. So this should be 3D10. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, 12 plus 6 is 18, 18 plus 2 is 20, 20 plus 10 is 30, 30 plus 6 is 36, 38, 48, and 50. Element number 50 is tin. Very good. So I'm going to change the answer under here. We have tin right there, which is perfect. Oops. A little unnecessary editing. There we go. So we knew that it was tin. Our highest energy level here is 5. So we have 5s2 and 5p. Notice it is split, and that's okay. You still want to add them together. So our valence electrons is going to be 4. Okay. All right, what questions do you have for me? Do you have questions on electron configuration longhand? Do you have questions on finding the valence electrons? If you have any questions, please feel free to reach out to me, and I hope you're doing well. Bye, guys.